Good. Awesome. Right, then let's get going. So, welcome everybody. Right, let's go down a quick run of show then. So first, a bit quick about me and what I do. Then we'll go into a quick bit of what technical designers actually do. Some tips on design process that will hopefully make your designs better and tips for basically working that. And then finishing on some tips for actually working in Unreal itself. Some notes for this talk as well is it's going to be primarily Unreal Engine focused. I've worked in Unreal now for a long time, but it doesn't mean that this can't be applied to other engines as well. If I say the word AI at all, I'm talking about NPCs, people running around in the game. I'm not talking about ChatGPT. I'm not going to cover that at all in any talk today. And some other points is every studio is slightly different and every project has its quirks. So this is based on my industry experience. Yours might differ. You might hear other things, but everything hopefully will be constructive. So first, then about me. I actually went to Staffs Uni a long time ago, back in the old campus, and I did manage to fish out my old GradX entry, which was in UDK a long time ago. Then I became a part-time lecturer here, finishing my master's in the first year that was actually up in Stoke a little while back. Then I moved to Flix Interactive, going into industry, where I worked basically through the levels as a designer. Something I just wanted to cover was I worked up to a lead designer, which was nice and fun. You know, as a lead designer, you get to make decisions about what's going on in the game. But it wasn't quite for me. In my experience, there's a lot of meetings, a lot of calls, a lot of reviews, and I prefer to be hands-on in the engine doing work. So I transitioned into a technical designer role. That is something that you could do in industry. You can kind of like twist your role into what you'd like to do. You can move around, that is possible. And finally, my games portfolio. Again, if you get into industry, you'll soon learn that you can't talk about most of the things that you end up working on. So as I was writing this list, and there's more games that could be on there, you can't talk about most of them because they either didn't come out, got shelved, or are still in development. But the three biggest ones I've got is I started out on Crackdown over 8 years ago now. Spent a lot of time working on Sea of Thieves, on things like the Arena, the Pirates Life update, which was the Pirates of the Caribbean, and most recently working on Mafia: The Old Country. So I've kind of worked on a wide range of games on multiple systems within those as well. So what does a technical design actually do? It's a pretty broad job role, and it will mean probably different things in different studios. But the way I like to think about it is we are a bridge between creative and technical. And what I mean by that is creatives are the dreamers. They are your creative directors, your game directors, your lead designers. They need to think big, and they need to think about what is this game going to look like when it's completely finished? What's going to look like in 5 years? Your technical or engineering side of things want a game that runs fast, runs bug-free, and is stable. And often those things are kind of at a heads with one another. So as a technical designer, what we want to focus on is still player experience, but we want to look at player experience at every level and define the finer details. So an example I've got of that is basically an interaction with a door. When you're going up to a door, you just press a button to interact with it. You want to know, well, how is this going to feel to actually work with the player? Should this be a hold? Should this be a single click, a double click? How long should the hold be? Are there any animations that need to go along with it? We need to think about how every part of the game is fun to use or feels good to use. That usually means we end up a lot in systems and using a lot of software. So it makes us very good problem solvers, good bug hunters, and bug fixers. That's, in the later half of development, when you've done a lot of the design work and you're making the game, there's a lot of bugs that needs to be fixed. And we're very good at hunting those down because we understand the systems and we understand the software. Also, because we work as designers most of the time, we get a good idea for where workflow can be improved with tools that we can make to help other designers as well. That means we end up a lot in engine, scripting, prototyping, and doing implementation. So some tips for your doing designs are kind of pretty broad here. This is basically like a list of things that I do in my daily job that have helped me basically be better, hopefully, at being a designer. The first is knowing your design sandbox. And what I mean by that is usually when you start in industry, you're going to be working on either a small feature or a part of a feature. You're not going to have full creative freedom to do whatever you want. So knowing where is my remit, how much creative freedom do I have for a mechanic or a feature is really helpful. It helps you focus your energies into the right thing. Also, it sounds simple, but think about the player's point of view. when you're designing systems and creating the checks and balances for gameplay, you can really get in the weeds about how things work and what choices should be made, if this, then that, going down the rabbit hole a little bit. It's always good to take a step back and think, how would I do this as a player? If a player comes up against a system who has no idea how it works, does it still feel good to use? Does it still make sense? Sometimes when you go through a system and you feel it feels clunky, maybe you need to reassess it. And finally, keep it simple. Most of the time, the best design is the simplest one, or the most elegant. Some good examples I've got here is in Sea of Thieves, the edge of the world is the Devil's Shroud. It's a big red sea, and you could sail into it and it sinks your ship. And, there's lots of caveats there. It's a little bit more involved than just, say, an invisible wall. That's because it's a multiplayer game. You could be being chased. If you were being chased by another player and you hit an invisible wall, that would feel exceptionally bad. But a while back, I was playing, I think it's Forza Horizon, and I was driving around the world and I saw a tunnel and I was like, I want to drive down that tunnel. And I went smash into an invisible wall. And you go, that might suck as an experience, but as a player, I turned around, carried on playing the game and didn't really think about it again. So it was a nice, simple solution in that case that was fit for purpose, even though the experience may have suffered a bit. Now, when it comes to making systems, when possible, we always want to think in the generic by building, create systems when possible and creating building blocks to use. Now, it's not always possible to create modular systems when you can, but it usually, in my experience, when we've created something, the second or third iteration of something, we're probably going to change it. And if you've built something that's very specific, it gets very hard to change. So an example of that, what might be, you're not building a car, you're building a vehicle. If you build a car and then somebody goes, we want motorbikes in this game now, you've got to chop your car up to make it into a motorbike. And it's going to be hacky, it's going to be buggy, it's probably not going to be the best. Whereas if you set out going, let's build a vehicle system that we could make a car with, or we could make a motorbike with, or we could make a boat maybe if we twist the right buttons. So again, it's not always possible within the timeframes, but thinking generic to begin with is definitely a benefit. And then the big ones for more kind of, as you get into the weeds of a design, are the edge cases and the pinch points. It's all the bits of design we have to do to make sure the game's going to function properly. So edge cases are when players start pushing the limits of the game. How do we make sure that they can't break the game and ruin that experience for themselves or for other players? And pinch points are when technical limitations are going to affect the design. How can we make sure that experience is maintained, even though technically we're going to have problems? Some examples of those might be for an edge case, if you're in a multiplayer open world game and you're doing a quest or a mission, how do other players affect that mission? How are they going to affect that experience for other players? And a pinch point might be a moving projectile in a multiplayer game as well. If you've got any physics in a multiplayer game, you're going to have to think about, how does this replicate over a network? How accurate can we be with this? If you move something too fast over a network in physics, you're probably going to create desync, and that's going to look different to different players and be a bit of a problem. If that's part of your design, you have to think about how you can maybe adjust your design to account for that. And when it comes to design process, you're going to have these problems and you're going to not have a solution. There's not going to be a perfect solution, so you're going to have to reach out. And it's fine to reach out to people and ask for direction to know what is the best approach to take this problem. The way I do this in all of my reviews is I do an ABC review method, which usually means here's the problem we've got, and we've got several solutions, and I'll list them out with the pros and cons of each one. Then I will make a decision about which one I think is best. That means if I go into a review meeting with my senior or my lead, I can be like, here's the problem, here's the pros and cons of each solution. I like B because of this reason. It instantly helps focus that conversation on the actual problem and drives that conversation forward. If you go into a review meeting, and it's very open, it can be very fun to talk about things, but you could spend 3 hours and not make a decision on it. So always pitch the solutions. Design documentation. As designers, we do a lot of documentation because documentation is cheap. But rare are the days now when we have a giant game design document that's pages and pages long. Documents are constantly changing as you iterate on the game. So especially as a designer, we're probably actually going to be reaching more a feature spec, which is for a feature mechanic, how does this need to work? And we need to know who this document is intended for. That means who's actually reading this document, what are they getting out of it? Most of the time, that's probably going to be engineering, needing to know how they're going to build it. Other departments, such as art, tech art, audio, can read it and understand what they need to do. So keeping it concise and clear is really important. Usually what I do with my documentation is I have a small paragraph at the top of the document. It's maybe only 2 or 3 sentences long. And that's all about the experience of something. So if we go back to our door example, let's say this door's in a horror game, that top paragraph might be like, ooh, when players go towards the door, they should feel suspense about what's on the other side. And as they open it, it should feel, scary or whatever. But then the rest of the document is going to be very to the point. The door's going to have a hold interaction. It's going to be half a second long. That's a variable I'm going to want to tweak. When the interaction starts, I want to play some PFX. I want to play some audio. When we play the animation, I want the collision to toggle at this point. Everything the engineer needs to know to build that. And also try not to repeat information in your documents. Every time you repeat a piece of information, you're missing a chance, you're providing a point for it to be missed in an update. It's quite often for documents to be revisited 3, 4, 5, 6 times. And if you miss an update, somebody else reads it and then builds that. And then you go back to and go, no, this was wrong because it wasn't updated. It's going to lead to a lot of wasted time. Most word processing, things these days have the ability to support links. So use them. Link to other parts of the document, link to other documents. You only need to be as verbose as you need to be with that. And in our door example, I might say, you interact with the door. I'm not going to explain the interaction system. I'm just going to link to the interaction document and say, go read that. Makes my document nice and small and to the point. Also, supporting assets, images, diagrams, flowcharts, and videos with annotations, either, talk over a video or, put text over the top. A picture really does paint 1,000 words. And I've got some examples here that I just kind of pulled out the old screenshot folder. One was for moving the storm in Sea Feeds in the arena. We would rewind or fast forward the storm to ensure all ships had a fair start. The one on the top here is how to dismember a corpse that I do with my friend at work. And you can look by that image, probably how that's going to work, right? So it simplifies the mechanics straight away. Also, an artist might look at that and go, okay, a leg is going to be 3 pieces, an arm is going to be 3 pieces. An engineer is going to know, they have different health values. We have these constraints between bits of body. It really helps flesh out that document. But something I will mention is this bottom one is actually a level design from the Pirates of the Caribbean stuff in Sea of Thieves. You don't need to be an artist to have diagrams in your designs. I spend a lot of time in MS Paint making crap drawings to go with my documents. Paired with the bullet points, I can tell you that image made perfect sense. So don't worry about making art if it's in a design document. As long as it gets the point across, that's what you need. Now, given all that, I always focus on the content first. Having a well-structured design document is really going to help when other people have to look at it. But when I start out, I literally just get raw thoughts on the page that make no sense to anybody else. But take a break, come back with fresh eyes, and every time you come back to that document, you'll see something that makes a little more sense. Oh, that doesn't read properly. That section should be here. This doesn't make any sense. So that's always a bonus as well. Next, prototyping. Obviously, we all love prototyping. It's great fun to make little prototypes and test out things. But the way I define a prototype was actually, I heard this from our head of design, Gareth, and it was a really nice, succinct sentence of, a prototype is a snapshot of a full experience that enables you to know and test what that experience will feel like. So when you are prototyping, you need to make sure you have a goal. What are you actually trying to find out? And some test criteria. How are you going to say whether you found that out or not? If you don't have these things, you're probably just making a crap version of the game for no reason. You need to know what you're actually trying to find out from that. Also, prototypes can actually have varying scales of quality. Most people think of prototypes like the Sea of Thieves prototype here that I think you can find on YouTube somewhere, which is, obviously it doesn't visually look the best, but it had fully functioning multiplayer and allowed them to find out whether those mechanics were fun and have that experience of a crew sailing together. Now, on the opposite side, this is actually a prototype on the bottom here as well. It looks a lot more polished, but that's because we were prototyping the actual visuals. In this oppressive, hostile world, is it going to actually be fun to go through fog and mist? We had a full kind of art implementation in that level to test that out. Now, it wasn't dynamic in any way, and if we wanted to do time of day, we probably would have duplicated the level and just hard-coded the values because that was easy. But the end result still looks polished and allows us to kind of assess whether that would have worked or not. Now, saying that, your prototypes are always going to be quick. That's the benefit of prototyping, is you're not abiding by coding standards and rules. So always expect it to be binned. If you go into your prototypes knowing none of it's actually going to make it in the game, it's there to find something out and then probably feed back into a design. It's going to be much easier to kind of get stuff done. When you are prototyping as well, obviously we are used to in-engine prototyping these days. Like Blueprint allows us to do a lot and really test the mechanics of our game, but we still do a lot of paper prototyping. Laying things out on the table, moving Post-it notes about to simulate flow is still really valuable and very quick and very cheap. Paint overs and mock-ups still are done a lot as well. If you want to know what something looks like, the amount of times I've taken screenshots of games, piece things together really hackily in Photoshop just to get a sense of what that might feel like. And finally, basic simulations. And what I actually mean by this is Excel. If you've got anything related to time, usually you can simulate that in Excel. If it's going to take me 10,000 hours to kill 1 million boars to get to level 10, I can change some numbers in a spreadsheet and get a rough hour count of what it's going to look like. And it's a lot cheaper than trying to build something, again, in engine. Iteration is something that I decided to kind of break out into its own thing here because it is very different from those earlier stages of development. When you're doing your design and your prototyping, that's like a cyclical process where one informs the other. And then once that design spec is sort of written, it's going to go off to engineering probably. They're going to build it. Once it comes back, well, now you can iterate on it. So we're adding or improving existing features in the main build. Now, when you are iterating on something, the first thing is to find out, well, what actually needs improving or fixing? And what I mean by that is you might get really vague feedback, like, oh, this feels floaty, or it doesn't feel quite right. And you'll play and you're like, I agree with that, but what exactly is the problem here? Is it a value that's wrong? Is it a logic that's wrong? Is the thing that we built in the first place not quite right, or it needs tweaking? So you need to find out exactly what needs fixing or improving. Then you need to define an approach for that improvement. Because now we're in full development swing, if you need engineering, if you need art or audio, you need to know if they actually have time to do it. So having multiple approaches for fixing a problem, if it's easy, fantastic. If it requires buy-in, then we've got to check the viability of that implementation. And finally, because we're in the main build now, this means the thing that we are making is actually going to get shipped. We have to make sure everything we do is to quality. And it's the boring stuff, like naming assets and finding them correctly, making sure all your code and script is performant and legible, because you might not be able to improve it again. Something that happens a lot in game development is as you get towards the end of development, those last kind of 9 to 6 months, every change you make is going to have an impact on the game, and it's something that could break. You might think, oh, let's just change this number in AI. It's only changing a number, that's safe, right? Well, if it's changed something on every AI in the game, do we now have to test every single fight in the game? That's a big investment. It's a lot of risk. And it's not something that's usually covered as you get further in development, you'll want to do a change as a designer because it would make it better. And the answer is, no, that's too risky. Fortunately, we're not doing that. So if you try and make everything you get the chance to do the best it can possibly be, you can make sure that it's to quality because you might not get a chance to improve it later. And then I've got a little example here, actually, of some of that. It's not the best example, but there is actually sound on this, which I will mute because it's actually quite annoying. We had oxygen in our game that drained, and during play testing, we found that players just weren't noticing because they were too focused on whatever they were doing at the time, and then they were dying of oxygen deprivation without knowing that they were low. So we didn't have a lot of time because we were on a bit of a deadline, so we added this flashing in the bottom left corner. There's actually, let me see if it's doing it. There is a very annoying beep that keeps going on. And then the vignette comes in. Now, it's not the most perfect experience, but we already had, I'm going to turn that off. We already had all these elements in the game already. We already had visor effects. We already had the UI and animation and the audio, and we already had the beep. So it was very easy to go, we can do this improvement. It allows us to get that into a playtest. It takes that problem out of the playtest that was skewing the results of other features. And we did it very quickly and very safe. We didn't introduce any more bugs. Right, so that was kind of like a general sort of overview of some design tips. Again, it's a bit of a smattering of things. And the next thing I'm going to go to is much more in the weeds in Unreal itself. It's in Unreal itself and its tools. And that's because when we are, working in Unreal and when I'm looking at portfolios, these are the sorts of things I'm going to be looking for. Also, it's some knowledge about how these things actually work in industry. But again, it might differ depending on studio or project. So the first one sounds stupid, but utilize the settings that Unreal gives you. My biggest pet peeve of doing any sort of blueprint is things not named correctly. If you name your functions and variables silly things that are vague, and when a bug comes up, I have to dig through code to find out what's going on, it's a huge waste of time. If you think about your project and you shelved it and you came back to it 3 years later, would you understand what was going on? So it sounds silly, but name things correctly and add tool tips where needed. But if your things are named correctly, hopefully you shouldn't need tool tips. Also, a thing I'll call out is your access specifiers. In default blueprint, everything is public, which is, I think it should probably be the other way around. And the significance of that is if everything's public, everything's accessible. And if you right click on that event graph background and it loads that little menu that pops up, if you've got a project with thousands of blueprints in it, sometimes you can right click and it takes 3 seconds for that little menu to pop up. So think about the amount of times you right click on an event graph to get that little menu. And if that took 3 seconds every single time, that's a lot of time that adds up via all the people. So that little setting can really help to manage your variables and functions correctly. Clean blueprint flow is something that should be pretty obvious, but I'm still going to bring it up anyway. And that means no spaghetti. We've all seen blueprint spaghetti, and we all hopefully don't like it. But also that means no single lines of logic that are a mile long, because it's just not readable. It's not understandable what's going on. Grouping logic on structure, dependency, relevancy helps make things really readable. We generally have a rule for our own blueprint, which is we don't do any bypassing wherever we can help it. Bypassing is in this top image here, where you can see that function B, I don't actually make sure function B there is called regardless of whether the bool is true or false. It has no dependency on that bool. So we use sequence nodes a lot to split that out. And then we can clearly see just by glancing at it, function B is not dependent on that bool. It's nice and easy to read. Mm-hmm. Now, part of that thing that I've only started using recently is collapsed graphs. They can use to be simplify presentation within a blueprint by packaging bits of code inside a nice readable graph, basically. You can see this thing at the bottom here is one of those collapsed graphs where I don't need to know what's going on inside that graph, but I know the input and I know the outputs, and that's nice and readable. However, collapsed graphs do also allow you to collapse graphs in collapsed graphs in collapsed graphs, and don't go too deep because then all that also gets confusing. On the same, I tend to avoid macros like the plague if I can. They're very good for very simple flow control, but they have one big fallback if you can't breakpoint inside a macro. So if you've got a macro that's important to the game and it's got a problem with it, it's very hard to debug. So I tend to just avoid them. And finally, comment boxes in code. If your comment box is just explaining exactly what the code does, that means you probably need to think about the naming you've got in your code. But if you have to do something a little bit funky, a comment box to explain why you've done that is really handy. The amount of times I've looked at Blueprint and gone, why is this the way it is, and done some investigation of whether it could be improved, and then eventually got around to the same conclusion as the person who originally made it, a comment box explaining that would have saved some time. Now, to say all that, here's some Blueprint that I did not that long ago. It's not the best, I'll admit that, but it's an example of we had an existing system that could not be changed. It was too late in development to change anything about it. This function returns a true or false bool, and we had to do the logic in here. So as much as I can say, do perfect blueprint, please, it's not always going to be applicable. But in this scenario, hopefully you can see if I was to go and stick a breakpoint on any of those return nodes, it would be pretty obvious how I got to that breakpoint. And then if I had to debug further, it's going to immediately cut down a lot of that time. Also, in this blueprint, if you've ever got to have logic that is a bit wonky like this, where you've got to return a function, it's running cheapest to most expensive logic-wise. So that means most of the time, hopefully, we'll exit first on the cheap stuff. And that's why it gets more complicated as it goes down, because it gets more expensive. Little optimizations like that really add up. Finally, blueprint references. So this is one that is not always going to be applicable to you, especially if you don't have any C++, but it's really good to know for going into industry. Most big projects won't allow blueprint to blueprint references. And what I mean by that is if you're casting to a blueprint type, or you have a variable that is of a blueprint type, that means the class was created in blueprint, it's just not going to be allowed. And that's because blueprint reference chains really slow down loading of the editor and the game. They can cause quite big problems. On an internal project, I think until we cleaned it up, it could take up to 20 minutes just to boot the editor until we went through and just got rid of all of the blueprint references. And now it's like 2 minutes. But casting is still fine if you cast to code classes. So that's perfectly fine to cast to a code class, but try and cast as high level as possible. So if your function is an actor, cast to actor, regardless of whether that object is that type. But also blueprint interfaces. They are basically the default method of communicating between blueprints. They generally are good practice anyway. They're a little bit slow, so don't go overboard. But again, if you are, in the industry, chances are you've probably got some engineering that can help out. But if you have to do blueprint to blueprint, interfaces are certainly the way to go. Now, this is a little in the weeds, I won't lie, but I'm going to cover it because it's something that I ran into that has changed the way I do blueprints. And it's not explicitly obvious that these things happen. So in pure, or your blue functions, call your pure functions, or every connected pure function once, which is your green ones. That means in a simple loop like this, we're going to call that bottom calculate in value function there 3 times in the same loop iteration. We're going to get this material 3 times in the same loop iteration. And because the loop itself is actually a macro, we're going to get the value from that array 4 times, even though they're not changing. Some simple caching of variables suddenly removes all those calls. Now, it's very in the weeds, and it's not going to matter if it's, say, if it's on begin play and it doesn't happen very often, sure. But if it's on a tick or a timer, or it's at an important piece of gameplay like firing a gun or swinging a sword, those things can add up. And again, if you've got thousands of blueprints in a project that are all pretty unoptimized, suddenly those things can really add up to big changes. If you had like 100 things in this array and you've got to call this function, then 300 times, and that's an expensive piece of logic, that's a huge waste of resources. So again, very in the weeds, but 20 seconds caching variables really goes a long way. This is a reasonably big one for tech designers, which is debugging tools. So I spend a lot of time, especially in the second, half of development, doing debugging, fixing bugs. And now we have tools in Unreal, like the Blueprint Debugger, which is really handy for being able to see how you got to a breakpoint. And then at that breakpoint, you can inspect any object and the data on it, which is really handy to figure out what's even going on. But also simple things like drawing debug shapes. This top image is actually something from CFEs about shooting cannons, which I depended on and stared at for weeks on end, trying to figure out how to make fights good, basically with skeletons on cannons. But the biggest thing I always shout about that I don't think enough people know about is the visual logger. I use it basically on a daily basis, and the amount of people I meet who don't know about it allows you to record a section of gameplay and then scrub backwards and forwards through that gameplay to assess the logs. Now, the really good thing about this, if you're trying to test a game and you're doing any sort of combat where a breakpoint would interrupt that flow, and you need to see the gameplay, like you're fighting an enemy, you're doing something that's very time-based, you can just hit record, play the game, not worry about debugging, and then open it up later. But again, a really handy thing is viz logs can be sent to other people. So if you hit a bug while playing the game and you happen to have the viz logger running, and it's not necessarily a bug for you to fix, but you can message that person and be like, hey, I reproed that bug that we've been having trouble reproing. I've got a viz log for it. You can send it to them and you can help them out. Finally, I'll just touch on Unreal Engine C++. Now, as technical designers, we don't necessarily need to know C++. It's not an essential skill, I think, for us, but it certainly goes a long way. I'll just call out Visual Studio Code, which is free, open source, but mainly it's an open source commercial license, which means you can use it anywhere. The real benefit for us is when we're trying to build systems in Blueprint or understand what we can change in a system to make it better, not everything might be accessible to you. So if you can quickly search through the code base to find any variables or functions that you could use, but you just can't see, is really handy. Otherwise, you're going to have to message an engineer, wait for them to have a look and get back to you, whereas we could just do that off the bat, and that's really handy. And then also being able to breakpoint code and assess data on objects. If you're working on a game, the editor will crash a lot. And if you're not connected to code, you'll just get a nice box that says, I don't know, we crashed. And that's all the information you get. And you have to send the logs off to an engineer again and get them to do the debugging for you. Whereas if you just boot from code, even you have no idea how it works, when you get the engine crash, you'll hit that breakpoint. You can at least call somebody and be like, hey, I've got that crash. Do you want to jump on a call real quick and look at this breakpoint? And that'll really help speed things along. Finally, as well, hacking in debugs, lines, shapes of viz logs. I do a lot of this, again, if I need to debug what's going on, or even debug just to understand how a feature works, because I want to make an improvement, then I could go and fill that whole code full of debugs to find out how stuff works, and again, identify what I actually need to change to make it better. And finally, everything else in Unreal. A few of you have probably heard me say this today, but we like T-shaped people, which means you know a lot of things and you have a few specializations. Especially as a technical designer, once we are designing those experiences, if we understand how all of the tools work, at least a little bit, we can make well-informed decisions about how things should work. Some notable things I'll call out here are Unreal Engine networking that did have a slide originally until I found out this was only 35 minutes. If you're working on a multiplayer game, understanding how Unreal Engine networking works is very, very useful. And even if you're not in Unreal, understanding how networking can affect your game. Working on CFEs for quite a while, most of our pinch points were networking issues, and it really does impact how you think about your designs. Some other ones that are coming up is the game playability system is now a really powerful tool I've seen on multiple projects, and it is very useful for doing all kinds of stuff. So knowing how that works and how to utilize it is very good. And finally, things like UMG, EQS, state trees. If you're doing any sort of AI or combat, you're probably going to have to know animation as well. Animation is becoming more and more ingrained with those sorts of areas. And finally, all the other tools that are available to you as well. Sometimes you've got to think of workflows, and Unreal will actually have a tool already for you. You just don't know about it. It's something that happens in industry is when you're working on a project, you're probably locked on a version of Unreal, and you're working on that version for quite a while. And then if there's a new version coming out, you might not know about the new tools Epic have added. So always try and keep up to date with what's coming in to the editor as well. Now, that was a bit of a smattering of a lot of things. I'm aware of that. But yes, we can move to any questions if we have time.
Sorry.
I just stay a little bit.
Hello. So, can I ask, as a student currently in games design, what would be the expectations in the industry for my portfolio if I'm looking into going into a more technical department after my course?
So, yeah, what's good for a portfolio from my perspective is when we're looking at a portfolio, you want to understand a person's skill set and kind of how they think to know that how they would solve a problem. So what I think always works is having simple case studies where you can go, this is a project that I was working on. This is a problem I hit, how I solved it and why I solved it this way. It gives us a really good insight into A, you could fix a problem, but B, why you fixed it a certain way and your thought process in that. And that's like a really good snapshot. Someone can read that in, like 5 minutes and understand something very simple. But you can still give people the opportunity as well to dig into the weeds on your project, on your portfolio as well. So always make sure, your portfolio is easy to read for somebody who doesn't have a lot of time, but give them options to go and look at really in-depth things like projects, GitHub, more details.
Okay, got it. Thank you. Anybody else? Thank you.
Hi, I'm curious what like a sort of either daily or maybe per sprint sort of job looks like for maybe not someone of your level, but maybe more closer to a junior tech designer.
Yeah, I mean, it's one of those things that can really vary a lot, again, between project and between studio. When we're running on a sprintly basis, you've usually got your work laid out for you in a way. You've got your tasks. And that's usually going to be a mixture of, depending where you're on development, if you're in more the design side of things, writing designs, going through reviews, iterating that document, maybe having to do a little bit of mini prototype to inform that document. Design tends to be very short cycles. Sprints I've worked on projects are generally 2 weeks, but on some design teams, we've basically done weekly ones because we're moving so quickly sometimes. We plan 2 weeks out, and then the end of the first week comes along, we've changed everything we're doing based on feedback or based on what we need to do. So yeah, it can be very varying, but generally, yeah, lots of reviews, lots of short pieces of work generally. And then if you're implementing, that actually might be a bit longer. And sometimes you'll get days where you go, today I'm just going to crack on. I'm just going to sit down and just kind of crack on building stuff. So it kind of does vary, to be honest, project.
Okay. Awesome. Thank you.
Hello. In uni, oftentimes for most modules, we're taught to go quite sort of in depth and detailed, or depending on the module, detailed or less detailed in design diagrams. But often it's hard to see how those are applied and used within industry because, often they're kept private or, under undisclosed or so on. In regards to how we sort of learn to, does diagramming everything to sort of often minutiae or so on in university modules, how does that sort of weigh up in actual industry application?
It sort of depends on how solid the feature idea is. If you've got a feature that's quite, high level, or it's something where you go, we really want to we've got this idea about how it's going to work, that's probably going to be a little more loose because you're trying it out. But if this is more like a feature, like we are having this in the game, it's going to exist, that's not in question, then you're going to get much more into the weeds and the detail about what's going on. So, those examples I put here were very lightweight because they were very, initial designs. And there was a lot of supporting text, to be honest, in the documents. But I've certainly done a lot of flowcharts in my time that have covered everything. So an example of that might be when we did the arena, we had a how to basically ban people when they leave games. And we had a giant flowchart that covered every single possible, action a player could do, even from outside of the game joining, to figure out, well, what needs to happen? Because in that element, you need to, if an engineer is going to build it, they're going to ask you this question: what happens in this scenario? And if you've already accounted for it in the design, again, thinking is cheap. If an engineer gets that problem, they have to stop work until we've made a decision. So yeah, those really intricate designs do come in, but more in the we need to build this and we need to kind of do all the theory crafting to make sure this feature is solid before we commit to building it, basically.
All right. But yeah, that'd be done.